Good afternoon, sir.
Good afternoon, Anna. God bless you. You are able to see my screen?
Yes, sir.
Thank you. So, in the last lecture, we have seen the flow out of the bins, and we have stopped at this particular point where we are going to store a free flowing solid, and then once we try to store it, we have a sloping bottom called as hopper. And as I said, that there are two types of flows will be encountered. The first one is funnel flow or tunnel flow. Funnel flow and tunnel flow. Suppose as soon as you open the wall, when the materials are falling straight, and then the material comes from the sides and then flow, that is called as the funnel flow. And if the flow is uniform, it is coming down, the level of the surface of the solids are uniformly coming down once you open the wall, then it is called as the mass flow. So mass flow is always a better flow when compared to funnel flow. So this all depends upon the angle here, angle of shallow we call it. So if this angle is more, what will happen? Then the withholding capacity of the solids in this particular region decreases. Suppose if this line is like this, what will happen? And here you have an opening. So at this point we will hold some amount of the solids. So because of it, we cannot create any movement in them. So if you have a sloping bottom, if this angle is increasing, so roughly this angle is greater than 90, less than 180. So if it is at 140 like that, what will happen? All the solids will free to flow. So this is how we design the hopper to prevent the to prevent the tunnel flow and then induce the mass flow. So mass flow is always a good one. Then we will see one more two definitions today. So when we are dumping the solid particles, so when the tipper comes, so what will happen when it is unloading the free flowing solids? So after they fall on the ground, they they form a pile like this. Okay, this is called as a pile, kuppa. Okay, and here we call it as angle of response. So what is the angle of response? Is the angle which is formed here by this line and the horizontal. Okay, the angle formed by this slope, okay, or this slope with the horizontal. Okay, so you have horizontal line. So this angle is called as angle of response. So this is a big question. So they say that what is the angle of response means what? If for a free flowing solids are there, concept is what? Angle of response is less. And if the solids are not so free flowing, then angle of response is very high. Once again, once we dump the solid particles into the ground, what will happen? A pile of these solids will take place like this. Okay, it will form. So this we call as pupa. Okay. So once you take this line and then horizontal line. So this angle between these two lines, this line and then the horizontal line is called as angle of response. Okay. And if the solids are free flowing, the angle of response will be less. If the solids are not free flowing or cohesive nature, which are having a property of sticking to one another, and if the friction is very high, and if they are irregular particles and the friction is very high, in that case, of course, the angle of response will be less. The definition of it. So you take a sand example. So angle between the slope and then the horizontal is called as the angle of response. As I said, for a free flowing solids, the angle of response will be what, this angle will be less. Okay. For cohesive solids and solids which are having intricate shapes or whose frictions are very high, for them the angle of response will be very high. Then, so you see here, when we are dumping the solid particles here, fine sand grain particles. So when we dump the sand particles, what will happen through the hopper? They will form, and then since they are free flowing, they roll away from here. So the height will be very less. On the vice versa, if take coarser sand of bigger sizes, and their shapes are intricate. Okay, so friction is also very high. So hence the angle increases. For other particles, supposing the sizes are more and the shapes are very difficult to predict, then of course here the angle is increasing. So this is the concept of angle of the response. Then we have a definition called as angle of friction. What is angle of friction? Angle of friction is a friction at which angle you are making with respect to horizontal to initiate the flow. For example, in a tipper, there are solids are present. So at what angle the tipper has to be raised to initiate the flow, not to start the flow, but to initiate the flow with the horizontal is called as angle of friction. So I gave this one. So on a plane we have a body, and then when force is applied, a normal force will be acting on it, and in this vector diagram it is shown like this. The resultant of this force is R. The angle between the resultant and the normal force is called as angle of internal friction in physics. Okay, but for us how to understand this? So this plate, now this plane will be slowly lifting. So when we lift the plane, what will happen? The angle of internal friction increases. Now at one particular point, this slab or this block will start moving. So once it is start moving, what will happen, sir? That movement, when it is initiated, the angle made by this plane and the horizontal is called as angle of internal friction. So we should know at what angle the solid should be tilted so that we can initiate the flow. That is the difference between angle of response and angle of friction. I repeat once again, angle of friction is the made by the sloping bottom, okay, of the pile, and the horizontal is called as angle of response. Okay, this is the big question. Then we have angular quotient of friction is for the plane has to be lifted to one particular height, or we have to tilt the solids to one particular angle so that the movement will start. Okay, that angle is called as angular quotient of friction. Okay, so before we complete this, let us see the demonstration of two things, that is the mass flow and then the tunnel flow. This is the example of a mass flow where the surface of the solids are uniformly coming down. Now this is the example of a tunnel flow. Then we have last example. So from a process, the materials are charged into this hopper. From there, it is discharged out on a belt conveyor. This is the feeder. This is the part of the hopper. And the materials are dumped. See how the pile extends. When we have a feeder, we don't have any problem. So that feeder will be continuously dosing to the conveyor belt, and the material falls into the system. This is called as a feeder to the next process. To ensure m dot constant, we do this. Tunnel flow. Two different particles are there in free flowing nature. So from a process, they are dumped in this tank. And Riemann, they are the channel creators. To avoid arching, they are present inside. And here one more cone is inserted. To avoid any type of increase in the pressure or jamming, etc. Because when the materials does not flow, there will be a pressure. When the material does not flow here because of the arching, what will happen in this particular location, the pressure increases. So thereby, there will be uneven distribution of the pressures will be there, and there will be a failure will be there. So hence, to avoid that, to avoid the accumulation of solid particles here or giving dosage continuously to the other one, so we keep a cone here like this so that it divides the flow, and from here sides it comes out. Okay. So this is about this slide, and then we'll go for the next concept, that is mass flow of beds. flow out of bins is what we are supposed to see today. Solids tends to flow out of any opening near the bottom of the bin, but are best discharged through an opening in the flow. So if you remember one flow sheet, I have shown that in case of a bin, we have a side opening, because having an opening from the bottom is very difficult, because we have to construct the foundation in such a manner that in that large bin, what is the bin, sir? The diameter of the cylinder is very large and the length is very less. For such kind of things, having a conical bottom at the bottom and then from there inside the ground is very difficult. So hence there we'll have a discharge from the sides. So this diagram we have already seen. But if it is possible, generally try to keep the outlet at the bottom so that we can ensure continuous supply will be there. So when you try to open the bottom wall, so what will happen? The solids which are resting over the wall, now they don't have any support because you have opened the wall. Okay, when you open the wall, the flow will be generated and they try to come down, and thus we initiate flow in the solids which are resting in the storage systems. Flow through a side opening tends to be uncertain and increases the lateral pressure on the other side of the bin while the solids are flowing. So, for example, if you see the here if you see, we are taking the feed from the side, isn't it? So when you take the feed from the side, here you have a concentration of the solids will be there, because this tank is full of solids, and when you take the metal from here and then put in the conveyor belt, what will happen? The solids at this place will be less, so hence the force exerted by the solids in this particular region decreases, and thereby what will happen? There will be non-uniform forces will be there on the sides of the walls, and the force exerted on the side is called as the lateral pressure. Okay, lateral pressure is formed because when the solids are exerting pressure on this peripheral area, this is called as the peripheral. On this area, if it is exerted, it is called as the lateral pressure. And the pressure is exerted, the force which is exerted by the pressure which is generated from the vertical force is called as the linear force. But here we are not talking about linear force, because we have a base at the bottom and then we have only side opening. So from here, if you start taking, what will happen? In this particular region, the lateral pressure will decrease, and here other side it will be uniform. So hence this entire vessel will have a system which is not having non-uniform distribution of lateral forces. So this may be again dangerous thing. So this also we are supposed to take care of it. Yeah, flow through a side of opening tends to be uncertain. Very good. And increases the lateral pressure on the other side. As I said just now, other side, because the concentration of the solids is more, so there from what will happen, the pressure will be exerted by the solids on the vessel walls, and that is the meaning of lateral pressure, that will increase, and thus there will be non-uniform distribution will be there. Lateral pressure on the other side of the bin while the solids are flowing from other side. The bottom outlet is less likely to clog. Clog means what? The process of stopping the flow in between because of various reasons. One of the reason is arching. The second reason is what? Suppose if you have cohesive solids which are having tendency to stick to one another. So what will happen? Even if you open the bottom wall also, the strength of the material is like that it will stick the solids and it will not allow the flow. That is the reason why when you take a Colgate paste and open the wall and then invert it, what will happen? Nothing will come down, because paste is a cohesive solid made up of paste is nothing but the material made with 1 minute. Yeah. So paste means what? It is a material which is exhibiting a property cohesive nature. So once you open the lid also and then you invert it, no flow will be there, because the strength of the metal is such that it is able to stick to each and every particle, and these particles sticking to the material of construction, and we cannot generate any flow. So in that case, what you should do? No other go, you have to apply pressure from the back side so that we can initiate the material to come out through the lid. Okay, so this is one of the clogging. Okay, clog means what? A procedure in which we are stopped, the flow is stopped because of some reason, and in case of free flowing solids, it is because of arching. In case of corrosive solids, it is the strength of the materials or adhesiveness of the materials, and does not induce abnormal high pressures on the walls at any point. So at a bottom wall, so when you have a bottom wall, what will happen? So this process of clocking is not at all there, because already we have seen that we can break the arches. When we are dealing with the free flowing solids, we know how to break an arches by keeping internal elements, or we can, if the size of the vessel is less, we can go for the vibrators, so that these arches, the bridges are broken, and we can ensure a continuous flow of material. That is one approach. And the second approach, what will happen? We will apply the force from the top, so that the material starts coming out from the bottom in case of the corrosive solids. So clocking or stoppage is generally not there when you are having a bottom outlet. Okay, and because of this, what will happen? The abnormal pressures will not develop at any point inside the vessel. Except in a very small bends, it is not feasible to open the entire bottom for a discharge. Commonly, a conical or a pyramidal hopper-like section is set at the bottom of the pin, leading to a fairly small outlet that can be closed with a valve. Suppose if you have a pin and you want to keep an outlet for it, then what will happen? You should choose a valve whose diameter is equal to that of the pin. And moreover, when you want to open the pin, what will happen? In our FM lab, some of the valves, butterfly valves, we are not able to open because of the, as time passes, rusting will take place, and then we are not able to open it. So frequent maintenance should be there. And here you imagine a bin is having a bottom wall on which all the solids are resting. So you can imagine the operator how much amount of pressure he has to put, force he has to apply to open the valve. So that is the difficulty. So apart from that, how can we construct a valve for such a big bin is again a question mark. So to avoid that, what we are doing, we brought the concept of hoppers. So in the hoppers, what will happen? The bin will have a sloping bottom, and the sloping bottom will be leading to a small diameter. And because of this, what will happen? We can keep a small valve, and once you open it, what will happen? Because of the sloping bottom, we can ensure continuous flow will be there from this. That is the meaning of the sentence. When the outlet at the bottom of a bin containing free-flowing solids is opened, the material immediately above the opening begins to flow. As we know very well that all the solids are simply residing on the wall on layer by layer basis. And once you open the bottom wall, the first layer which is resting on the wall will open, and then that will start moving out. Similarly, once that is evacuated, the second layer will be, third layer, fourth layer, like that. We can generate a motion inside the solids which are stored inside the bin on the top of the valve. And once the valve is open, we can generate the flow. One of the two flow patterns will develop depending upon the steepness of the valves. Please remember steepness of the valves. If you remember, I said here, yeah. As I said that if we try to increase the angle between these two, now it is around greater than 90, say it is 110, you go up to 160, then what will happen? You are increasing the angle. So what will happen? There is no chances of formation of tunnel flow. There will be only mass flow will be there. That is the meaning of the sentence. Yeah. One of the two flow patterns will develop depend on the steepness of the walls in the bottom section of the bin and on the coefficient of friction between the solids and the bin walls. So not only the steepness, but also the friction point is also very important. If the solids are exhibiting high friction, then what will happen? They will be, interlocking will be there, and because of this interlocking, the flow cannot be generated. So the point is how to ensure free flow when we have materials which are having high friction. So as in the video we have seen, there are internal elements are there, inverted V shapes, isn't it? And at the bottom we have inverted cone. So these are the items which are going to keep inside the bin to ensure free flow even if the solids are exhibiting high friction. This is the meaning of it. Then mass flow occurs in a cone bottomed bins with a tall steep cone. Angle is very high, and then mass flow will be there. All the materials moves downwards uniformly from the top of the bin. Okay, that is the tunnel flow. Then that is the mass flow. Then tunnel flow develops in the bins with a shallow cone angle with the vertical walls and a central opening at the floor. So what will happen, sir, here? So when, as I said, this line is going top, what will happen? When this line is going top, what will happen? We are going towards the funnel flow. So this will be able to hold some solids, and these solids will be holding some solids here, some like that. What will happen? Only once you open the wall, this space is free, and the solids which are resting here, they try to come down. Then the second layer, third layer, like that. So what will happen? This gap whichever is there, now that will go to the top of the surface, and from the sides of the solids will be coming out. So this is what we have seen in the video. This is the example of a tunnel flow in which we are giving chance for division of non-uniform forces on the sides, and then the metal may fail. So what we want is, once you open the wall, a level of solids should uniformly try to come down. That is important. Yeah. Tunnel flow develops in the bins with a shallow cone angle or with vertical walls and centrally opening in the floor, where vertical column of the solids above the opening moves downwards without disturbing the materials at the side. Why is that at the sides? Because the angle supports the solids, and these solids will be supporting other solids in the layer, and that is the reason why in the sides we cannot generate any amount of the flow. That is the meaning of it. Then eventually lateral flow begins, first from the top layers of the solids. A conical depression is formed inside the surface of the mass, and the solids at the bin floor at the near the walls are the last to the leaf. So what will happen here? So once you open the wall, the layers which is just above the wall, it will be open, and they try to come down. The second layer which is on the top, it will come down. Third. So like that, this gap will go to the top of the layers, and from the top what will happen? The solids will be slipping, and they fall into the gap which is created by the evacuation of solids. And then what will happen to the fate of solids which are adjacent to the opening? They never move. Okay, unless and until you give vibrations for the evacuation of the solid, nothing is going to happen. So they remain there only. The material slides laterally into the central column of the at an angle approximating the angle of internal friction of the solids. What is the angle of internal friction? The angle to which the equipment has to be raised so that we can start the flow to take place. So here how we should understand? So once the gap enters to the top, what will happen? The material which is adjacent to the gap, they try to fall down. So hence there will be a sloping bottom will be there. And when this angle is equal to internal friction, then only the solids will start moving. That is what we are supposed to understand. If additional material is added at the top of the bin, at the same rate of the material is flowing out of the bin, the solids near the bin walls remain stagnant and do not discharge no matter how long the process starts. So once this process is taking place, once you add additional materials also, the same thing, that is the materials which are present adjacent, they will not move, but only at the central zone only the particles will be moving down. During the flow, the pressure inside the solids increase from 0, and the top surface at the maximum of the solid, top of the upper section. Then the the pressure drops to 0 at the discharge. Now, what is this pressure which is talking about? First of all, what is pressure? Pressure is nothing but force per unit area. What is force? Mass into G by Gc. So whenever there is a solid is there which is having some amount of mass, then some gravitational force will be exerted on it, and this mass will be exerting some force on a container on which it is resisting, or on the solid particle which is resisting. So when there is an accumulation of solids is there, then of course this pressure will be more. And once you remove the bottom wall, what will happen? The solids will move from the bottom, and when they start moving, what will happen? There is no exertion of pressure will be there. So from 0, it becomes to a maximum value if the movement is not there. That is what we are supposed to understand here. Then the rate of flow of granular solids by gravity through a circular opening in the bottom of a bin depends on the diameter of the opening and the properties of the solid. We know very well, if we have a bigger diameter, we can ensure the flow perfectly, and at the same time, what is the meaning of property of the materials? The friction should be less and the sphericity should be very high. What is sphericity, sir? You know the definition of sphericity, and if the value of sphericity is near 0.9, that indicates that the molecule, the solid particle is near to a regular shape, and then its intrinsicity is less. Okay, so these are the properties which we are supposed to understand. Within a wide range limit, it does not depend on the height on the bed of the solids. So height on the bed is immaterial. It mainly depends upon the properties of the solids. and the diameter of the opening. With the free flowing particles, the rate of solids flow m dot varies with the diameter of the orifice raised to power of n, where n is a constant, where d naught is the diameter of the discharge opening or the opening from where the solids will be passing down. That is the value of d naught. So m dot will be varying with the d naught raised to n, where n naught is an exponential constant and it is a constant. It varies from 2.8 from angular particles to 3.1 for the spheres. Now, with cohesive solids, that is very important. The solids which are having a tendency to stick to one another. Here we have one more difficulty called as rat hole. Let us see what is a rat hole. So, what are cohesive solids? Cohesive solids are those solids which are having a tendency of sticking to one another. So, these solids, they are not only sticking to one another, but they also stick to the container surface. That is also very important. So, with cohesive solids, it is often hard to start the flow. As I said just now, in the toothpaste, we open it, no flow will be generated. Once the flow starts, however, it again begins the material directly above the discharge opening. So even if you open the bottom wall on the bin or the silo, depending upon the gravitational force, if it is able to create some flow, then a mass will come out from the circular opening, which is just above the wall. That is the first point. Directly above the discharge opening. Frequently, the column of the solids above the outlet moves out as a plug. So what will happen? Once you open the bottom wall, and now above the solids, above the opening whichever is there, the solids which are resting, the mass which is resting, that will try to come down. Above mass will come down. Above mass will come down. So like that, what will happen? A gap will be created inside on the top of the wall. And after this wall, what will happen? There will not be any amount of flow there because all the solids are having enough strength to hold the materials with itself. And the gap which is formed is called as rat hole. Okay, this is called as rat hole. Once again, once the flow does start, however, it again begins in the material directly above the discharge opening. That is only moving because it is now the bottom, nothing is there, so no support is there, so it starts moving. Frequently, the column of the solids above the outlet moves out in the form of a plug. What is a plug here? We have to understand that it is a cylinder, it is a mass. It is a full cylinder having a mass. So once you open the bottom wall, a cylinder comes out from the bottom and leaving the solids rest of it because they are having enough strength to hold other solids. Leaving a rat hole. So the gap which is left out by this plug is called as a rat hole. With the nearly vertical sides, sticky solids and even some dry powders adhere strongly to the vertical surfaces and have enough shear strength to support the plug considerably diameter above an opening of discharge. So once you open the bottom wall, the solids will come out. So a cylindrical part will come out. Then afterwards flow will not come. Why? Because of the force or the material's nature to stick to one another. Because of it, what will happen? Remember, what is the shear strength here? Suppose you are catching something which is from the top floor. Okay, you are putting your hand down. So what will happen? It is a shear force. So the material will try to go down, but your hand will be resisting it, and you will be catching it and moving it in the opposite direction. So that is the meaning of shear strength here. So that will be more to resist the particles. So hence there will be a rat hole will be present here. Then, thus to get the flow started, to keep the materials moving down, vibrators on the bin walls, internal plows near the bin floor. What is the internal flow, sir? That is the feeder which we have seen. The plows will be rotating. So in other words, a similar case of impellers, that is which is rotating here, and the plows will be what they will do, sir? They will be pushing the solids from the backward direction, and they will push to the bottom of the container so that they fall in a conveyor belt. They will be going out. Or else what you can do is, if the tank size is very less, you can give vibrations to the vessel so that it will be breaking that arches or then cohesive nature of the materials, and then break the shear strength of the materials, and then we can ensure free flowing of the material. Or jets of air in the discharge opening are often needed. So from the bottom we give a jet of it so that these materials shear strength or the arcing will be destroyed, and we ensure a free flowing there. But in majority of the cases, we will go either for the vibrators or for the sloping bottom with the shallow angles. The discharge opening should be small enough to get readily closed when the solids are flowing, yet not so small it will clog. So he is saying that we are supposed to stop the flows. So now the wall which is used for sudden stoppage and sudden opening is the butterfly wall. Remember this, we have seen only ball valve or we have seen only gate valve. But here in the instrumentation process control, the valve which is used for sudden stoppage and sudden opening is called as a butterfly valve, which is used in IPC. So its size should be less. If its size is more, what will happen? As I said, the machine or the operator has to do a lot of work to open it and then to close it. It is best to make the opening large enough to pass full desired flow when it is half open. So we should see that what is the flow which you are going to generate it. How does you know this? That is the first question. Means what? What is the loading on the conveyor belt? Means what? How you are going to mix the material? Means what? You should know what is the reaction which is taking place. For example, you take the case of municipal water treatment method. First step is what? You will be measuring the hardness. So after measuring the hardness, the water, then accordingly we will be measuring the quantities of alum, quantities of soda ash and quantities of activated carbon to be added. That is measured. So and then what will happen? We will be opening them because you know the quantity and you know the flow rate. So hence we will be fixing how much amount has to be discharged into the conveyor belt. So like that we fix the values of m dot for 3 conveyors and then we fix it so that the alum or the soda ash or the what do you say the alum, soda ash or the activated carbon, they will be falling on the conveyor belt, and the conveyor belt should also move with a constant velocity. Then it will move into the mixing tank, and after mixing tank it goes to the reactor. So everything is kept constant. So from the material balance we try to understand how to keep m dot values are constant. So here once you fix the m dot value, he says that in the design, once the valve is half open, it should contain m dot. That is the meaning of it. Not fully open. Okay. So once the valve is fully open also, you get double m dot. So half open, you should get m dot. It can then be further opened clear to partial choke. So operational we have some clearance for it. If the opening is too large, however, the shut off the valve may be hard to close and control the flow rate will be poor. So if you have a big valves, as I said, we will not use big valves, but because of hopper assembly. So if we are using bigger valves, then this is a difficulty we are going to encounter. Okay, so this is about the flow out of the paints. Then in the unit number 2, we have completed the first part of the R. So now let us see the next important thing, called as conveyors. Now in the unit 2, whatever I taught to you till now, it will coming. It will be a question about the R. Then afterwards you have a choice. In the choice we have conveyors. Okay, conveyors. We have examples. Let us see one by one in detail. First one, conveyors for materials and handling. So why we are going to use, just now we said in the municipal water treatment method, we have after the silos, we are having conveyor belts. So what is the conveyor belts? Conveyor belts are the materials which are used for transportation of materials from one point to another point in the chemical industry. You have seen this as a drag line, okay, not a tractor shovel, drag line you have seen it, where we are using a screw conveyor. So that we will be adding the materials to it, and that will take the materials to one point to another point. So generally a very large scale industry, cement industry, okay, and then urea industry and sugar factories, paper industry, these kind of industries will be having a conveyors. And in our Hyderabad, we have a place called as Sanghi Polymers. That is the only company in Hyderabad which is fully automated. And the number of people who are working in a shift will be less than 10 or 10 like that, because all the things are done by the process controls. So only one operator, one engineer will be there in the distributed control system room, where he will be observing all this thing in the prologue flow sheets, and then he will be controlling the flow right from discharging of the materials. It is automated. So first process for them is a pneumatic conveyor, in which the material ethylene glycol comes from the Patal Ganga Reliance plant, and that comes to Hyderabad, and there from there onwards discharging into the system is also done by pneumatic conveyors. So involvement of human beings is very less. So if you have an opportunity once, you can visit Sanghi Polymers. It's a very good industry. Then what purpose we are going to use them? That is important. So we are using them for improving the productivity. So if you keep human being, for example, you take the case of Singareni College, where we produce tons of coal per day. So what will happen? We are below the earth crust. The human beings will go several kilometers, and then they will go for the mining of the coal, and that will be brought to the surface. And suppose if you ask human beings to keep it on a tatta, and then what will happen? The total production can be only in kgs, not even tons. So, but if you keep a conveyor belt, okay, so when you keep a conveyor belt, what will happen? First of all, transportation of solid human beings to the zone of mining is very less. It takes less amount of time, and then moving inside the mine, because inside the mine is also very big space. So with the help of lights and then a transportation facility, they move inside, and then after the extraction of the coal, they put it on a belt or the apron by apron conveyors, and from there they will be discharged to the surface of the uh, say ore, and thereby from there we take it outside. So if we don't keep machinery, what will happen? We cannot get high productivity. So to increase the productivity, definitely we are supposed to go for the conveying systems. And in case of a heavy plant, this is a must. As I said, Gayatri Sugars, we can see this, and then as I said, Sanghi Polymers also we can see this. And big industry, paper industry, or say for example, any of the bottling plants where the material, where the medicine is put into the bottles, and then we have put a label on it. For example, Hindustan Beverages at Maulali, it is also conveying systems is there, because pouring that Pepsi or Coca-Cola in the particular liquid and then selling it and having a labeling, if you keep human beings, it takes a lot of time. So automation is very important. Wherever automation is there, definitely below we have a conveying system. So hence we conclude that for improving our productivity, we are supposed to go for the conveyor belts. That is important. Then next one is continuously they are working. So we need not stop them in between. For example, you take human beings, they work only for 8 hours. In the 8 hours also, we can't expect 100% of work from them. In between, they will go out for lunch time and etc. All these things will be there. So, but if you keep a machine, the machine, if it is functioning properly and it is maintained properly, this is very important. The machine should be continuously functioning and it should be maintained properly. If these are the two situations are there, then of course 24/7 throughout the month, throughout the year, we can extract the work from it. That is the beauty of the conveying system. So they work on a continuous basis. Now the second one is dedicated for a particular work. So they don't do multiple tasking. So their aim is to transfer the materials. For example, take storage of coal. So storage of coal in the fire, it is there. So what will happen? From the fire, it has to take the material to the boiler or furnace. So directly we use a what is a conveying system. So the operator will be charging the solids onto the bulk conveyor, and the belts will be moving and continuously they will be discharging to the furnace. Okay, that is the only task it will do. It will not do any other task. If you ask it to do some other task, then we have to change the design. So that is the meaning of it. Dedicated only for a particular work, place and a product. Place means what, sir? From where we are going to transport it. How many belts, how many lengths of belt conveyors are used? This is important. And similarly, what is the product we are going to use? For example, you are using cement bag. We use different types of conveyors. You are going to use pulp. After the extraction of the sugarcane, the pulp is transferred to a regenerative furnace. So there we are going to use a different type of pulp. And suppose if you are going to use coal, so it all depends upon the nature of the material is what, its volatility in nature, its density in nature, its shape in nature, etc., etc. will come into the picture. Then the flow rate is also regularized. So by reducing or increasing the RPM of the pulley, we can control the mass flow rate. As I said just now, in the municipal water treatment method, first step is what, we should do the analysis for the salt which is present in the raw water. Based on that, we are supposed to dose it. Means what, how we are dosing it, quantities are there, but how you are going to add to the conveyor belt. So RPM of the conveyor belts are very important. If they move very fast, more amount of chemicals are dumped into the mixing tank. It is a bad thing. If they move slowly, then what will happen? Then again, the process of cleaning will not be completed. So the RPM of the conveyor belt is decided by the design engineer based on the input raw material. Input raw material is what? The hardness of the raw water which we are supposed to treat it. Then flow rate is regulated means what? Yes, as I said just now, we are going to keep the flow rate constant, that is RPM of the conveyor belt as constant. So these are the most important things which you are supposed to treat. Okay, these are the plus points of using a conveyor belt. Then material conveying system consisting of following assemblies. What are the main main materials which are present here? That is also important, which we are supposed to see. The first one is the drive unit, the load carrying members, the tractive materials, intermediate supports and beds, and the take-up device and the overall framework. So these are the most important things which are present in a flow sheet of a conveying system. The first one is the drive unit. So we should have an electrical motor, and as I said just now, if you keep an electrical motor, we are supposed to reduce the RPM, or else what will happen, the materials will be flowing very fast. Means what? Controlling the RPM of the motor is very important. So that is the drive unit, that takes care of the drive unit. Then load carrying members. Who is going to carry the loads? A material will be carrying. For example, you take belt conveyors. So in between the belt conveyor, I said belt conveyor is what? The belt is the material which is carrying the material. What should be the nature of the material? Is it made up of canvas cloth? Is it made up of a plastic material? Is it made up of iron chains? So this is the meaning of load carrying members. So if it is a canvas cloth, what type of materials we can handle it? If it is a elastic material, rubber belt, then what type of materials we can transfer it? And suppose if you are using iron chains, then how to fit your product into the iron chains, because iron chain will have gap in between. So if you have any other devices so to support, that is important. So tractive members. Tractive means what? Creation of tension inside the belt. If the belt is having some play, or the distance between the pulleys is X and the length of the belt is more than X, then there will be a play will be there, because the loose ga ఉంటుంది. So it should try to have a perfect tension inside, so that the entire energy which is given by the electrical motor, driver motor, will be transferred to the driven pulley. So then your activity of transporting materials will be satisfied. If not, they will be moving very slowly. You are giving energy to the machine, but it is not good. Okay, so it is not used for the purpose. Then intermediate supports and belts. So intermediate, not only that. So a belt conveyors are used for different change. Conveyors are used for not only in one particular direction, but in the change in the direction. Sometimes you may have to go in the vertical direction also. So how to go for such kind of things? So hence we should have special designs for it, which will be calling as intermediate supports and belts. Then the take-up devices. Okay, now once you take the material, you discharge it. So where it falls, that is important. So somebody should be there to take the material which is coming in a belt conveyor, isn't it? So this is the meaning of take-up device. And finally, we should fix all this in a particular framework. So this is the meaning of it. So every person, a person will be in charge of it, who will be monitoring the entire overall framework functioning of the materials. Especially remember how the papers will come out. So the printing of newsprint, okay, will start at 12 o'clock or 1 o'clock. But next day morning by 6 o'clock or by 5 o'clock, it is there in every part of Hyderabad, every part of Telangana, every part of the world. How it is possible, sir? So conveys are very important. So how precisely they have to work and how they have to be maintained. This is very important. What are the types of, so this, we not bother about this much about it. When we see the individual things, I'll come back to the slide 100 times to explain you how the driver unit will be there, what is the load carrying materials, what are the tractive materials, everything we will see once again this slide. So in a general brief introduction, what is a conveying framework, we are seeing this slide, and then we again come back to this slide after seeing individually what are those things. Then the next one, what are the types of the conveyor belts? Okay, there are only 4 types, and in our examination, belt and screw pneumatic conveyors are frequently asked, because chain and screw conveyors are intricate. So to draw this diagram also, it's very difficult. So because of this, he will be asking more amount of questions on belt conveyors and pneumatic conveyors, and in majority of the cases, he will be asking you only one question: explain in detail with the neat flow chart and the working of any 2 conveyors he'll ask. So if you are having some intelligence and experience skills, you can go for chain and screw conveyors also, no problem. But generally there are 4 types of conveyors are there: belt conveyor, chain conveyors, screw conveyors, and pneumatic conveyors. In the belt conveyors, of course, we are going to use a rubber belt or a canvas glove, which will be in between 2 pulleys. One pulley will be driven by means of an electrical motor. The other one is connected to a flywheel. Okay, so like that we transfer the materials from one point to another point. Then in case of a chain conveyors, as I said that if the weight of the material increases, okay, if the weight of the material increases and it is having some sharp corners, or its Density is also very high. In that case, of course, the belt will not be there because a belt will be subjected for elongation. So as soon as the material comes in between the 2 points of the conveying system, it will try to elongate, and that may damage the life of the belt also. So depending upon the strength of the material, we are supposed to go from belt conveying system to chain conveying system. Similarly, if you want to convey the materials in a closed system, for example, we have seen any number of applications of screw conveyors in our mechanical unit operations till now. So there we can use the screw conveyors where the materials not only scrapped but also are advanced from one point to the another point. And the last one is pneumatic conveying, where we are going to use the force or air. You know very well that when we flow, when the air is blowing with a high velocity, when you keep small particles, that drag force exerted by the flow on the object is very high, and the object starts moving in the bulk of the air. And thus we can create a movement in the solid particle which was initially resting. So now this will be moving along with the air. So this entire process will take place in a closed contact. Okay, it can be contact means what? It is a belongs to the family of pipe. The pipe is generally which is having circular in diameter. If it is square, we can call it a contact. So inside the contact only, the material will fall as the air, compressed air, and the solid particles will be moving. So at the other end, of course, we are going to stop the flow. How do we stop the flow? You can keep a cyclone separator followed by a fabric filter so that all the solid particles are taken out from the gas. They fall from the bottom, and the gas can be used for reuse. So here also the usage of gas is important. Pneumatic means what? Usage of air. But suppose if air is having a reactive character to the material which is used for transportation, in that case, of course, you are supposed to use nitrogen. Okay. So when you use nitrogen, what will happen? The operating cost will increase. But here we need not worry about that, because once you fill the system with the air or nitrogen, it will be present as it is, because we are not letting out the air to the atmosphere. So after the air which is coming out from the cyclone separator or the fabric filter or electrostatic precipitator, the air can be reused for this purpose. Okay. So these are the four conveying methods which are available for us for the transportation of the materials under the concept called as conveyors. Okay, belt conveyor, chain conveyor, screw conveyor, and pneumatic conveyor. So let us see the first slide of the belt conveyors. Belt conveyors were discovered by Leicester in the year 1868. So in the England, when the Industrial Revolution took place, where people started opposing not to work because of the drastic working conditions. Then what has happened is management cannot simply sit enough, because it wants to get the profits. So when human beings are not resistant to work, so they should consider two things. How can they increase the productivity? They have to take even human beings also in their arguments also in consideration, and then try to improve the system so that they get more amount of the profits. So thus, scientist by name Leicester has discovered the belt conveyors in England, especially when the Industrial Revolution was taking place in the British. Belt conveyors are used for light loads. As I said, that it's a simple one. Two pulleys are there. One pulley is driven by means of an electric motor. One pulley is connected to a flywheel or a bearing, and then we connect these two by means of a elastic material, generally belt, so that it firmly fixes both the pulleys. And then once the pulley starts, what will happen? The belt will move. So as the belt is moving, if you keep any material there, what will happen? From one pulley to other pulley, the belt can be, the material will be moving, or we can say the material is conveyed from one point to the another point. Now here, the belt can take lighter loads because it is not used for using coal or the materials whose densities are very high or which are having some intricate shapes, or for irregular particles, it is generally not possible. But currently, the belt conveyors are used only for the transfer of energy from one point to another point. So any machines are there. Okay. So in our lab, we have some machines where we have a belt conveying system. The main purpose is to drive the machine. How to drive the machine? By means of an electric motor. So at the electric motor, what will happen? We have a pulley that will be rotating. So this torque will be transferred from the electrical motor to the machine by means of a belt conveyor. So the application of belt conveyors for conveying is almost restricted. It is used only for the transportation of torque or transfer of torque, your twisting moment. Unit is Newton into meter from one point to another point, so that we transfer the rotational energy to some other energy where we can use it for a purpose. Okay. Then belts are used for transmitting motion as well as load carrying in many of the applications. So still somehow if you find that it is there, we can use it for the purpose. But we should see that the nature of the material is very important. Its density should be very less and it should not have sharp corners because it may spoil the life, it may spoil the belt texture, and thus the life of the belt can be reduced. Then belts are light in weight. As you know very well, the elastomers, the plastic material, the densities are very less. Okay, so with this we end our class. We have some time. Yeah. Yeah, belts are light in weight, and then what we can do is, as I said just now, so we can select a material whose density is very less, and at the same time they don't have intricate shape, and at the same time, if the materials are powders, as I said just now, density matters. So if you have powder particles, there is a chance that when the belt is rotating, the small particles which are there, they can spill out from the belt. So you are keeping 5 kgs of a material, and by the time it goes to the destination, if there are only 3 kgs, then of course this is not possible. So hence we should try to modify the designs according to our own requirement. So first we have to specify our problem. What is our problem? And based on this problem, we will be using at least any one of the 4 items, but internal designs we can modify it. The advantages of the belt conveyors are simple in construction. Very good. They are very simple in construction, as it means what I said just now, that there are only one driver, electrical machine will be there, pulley will be there, and another pulley will be there connected to a shaft where we have another network. Either we can have a flywheel or a bearing, whatever it is. And then a belt is present. And now what are the costly parts in it? Nothing else. So only care should be taken what type of materials we are going to put. So first try to understand what type of materials are to be used for belt conveyors. That data you should have. So they are very simple, and then they are highly efficiency because of only one point. The belt will firmly held the 2 pulleys tightly. So if there is a play there, and loose play, okay, then there is a problem of energy losses. So as long as you see the nature of the belt, so of course efficiency is very high. Whatever the electrical energy which we are giving, converted to the desired work, it is able to do it. Then low frictional losses resulting in low power requirements. So as I said just now, when the belt is firmly holding on the pulley, then definitely whatever the energy is given by the machine, that goes out to the output. So there are no friction losses are here because there are no bearings are there are no solid particles are there, there are no other anything are there. Just you see that the pulley moves perfectly, the lubrication for the driven pulley, not the driver pulley. Driver pulley is connected to electrical motor. Driven pulley is there for other side. The lubrication lubrication should be proper for the driven pulley. So what is a driver pulley? Driven pulley we will see in the next slide. Don't bother about it. Then economy in upkeep. So since its cost is less, it is simple in nature. When we find that we can have a suitable application for this, then we don't have any problem to go with, because we can have in our own budget. There is no problem for it. It may be horizontal or inclined. That is important. As I said just now. So a conveying system not only should transfer the materials from one point to another point horizontally, but even in the vertical directions also we are supposed to see that the materials are transferred. So in that case, there will be changing in the directions will be there, inclinations will be there, everything. So how to use this, that is important. So here the belt conveyors can also be used for horizontal purpose, and even in the inclined purpose with an angle between the 2 pulleys, that is important, or a combination of it. Convey materials up and down in an incline. So whether we can send them from the bottom to top or top to bottom, provided as long as the materials are not slipping, we are going to use this conveying belts, no problem. There are 2 main types of the belt conveyor. The first one is the flat, and the second one is the troughed one. Troughed one means what? Yeah, the flat one is an ordinary one where the plane surface will be there of the belt. We see the diagram, plane surface. But in case of a troughed one, what happens is that there will be a trough like of thing insert element will be inserted in the bed so that we can hold more amount of the material, and this material will not be spilled as the material moves away from the driver pulley. So to take care of that, we can have the concept of trough, TROUGH. From there we got the move trough method. A flat bed conveyor is generally used for bags, bottles, boxes, and other packaging materials, especially the packaging materials. As I said just now, for example, you have a Benadryl syrup is there or a Gelusil syrup is there. Do you think that human beings will put the medicine into it and then put the label and then put the cap to it and then seal it? No, 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 no. Who is going to do it? The human beings will not do it, but the machines will be doing it. So since the machines are doing, and we want the materials to move from one point to another point, first step is bottle will be inserted. Then the cleanliness, of course, that is a different story. Then the material will be added to it. Then we are supposed to put a cap to it, and then put a seal to it, and then put a label to it. So this many activities will take place. So when the materials is moving, it should move to all these job works. Then the materials, then the job will be done on the object. So how they move? They move because of the conveying systems. Okay, thank you.